So hi guys, today's topic is about system design and its implementation. Oh, what is meant by system design? So basically design means designing something or it's a blueprint for doing something. So it's also similar like the original design. So system design involves defining the architecture and components of a system. The implementation is the process of bringing the design to the life. So I already said the implementation is a process of bringing the design to the life. Next, why system design is important? So it is important to ensure efficiency and maintainability. It enhances scalability and performance. It reduces security risk and downtime. SDLC, System Development Lifecycle. The system development lifecycle involves requirement analysis, system design, implementation, next XD, then deployment, next and last maintenance. So first key components of system design. The key components involves data flow, user interface, database structure, API and integration. System architecture types. The system architecture types are monolithic architecture, microservices architecture, client server architecture, peer to peer architecture. So, first, monolithic versus microservices architecture. Monolithic means all components in one application. Microservices means independent services communicating via APIs. So, first, monolithic means the all components. The structure contains all the components in an one application. But in microservices, the services are independent to communicate with the APIs through APIs. Its pros and cons are monolithic are very simple, so it's easy to design. But microservices are scalable. Client server versus peer-to-peer architecture. Client server means centralized control. Example web apps. Peer-to-peer distributed communication. Example torrenting. The client server um, basically known as uh, for one for one primary system there can be many secondary devices. For example, if I share something through the Bluetooth, so I'm a server and the recipients who are all receiving the data are all the clients. So here client server means one server and many clients. But in peer to peer means it's like a point to point. The both system can act as both the server and client. So make system design principles. The system design principle key system principles are solid principles, separation of concerns, loose coupling, and high cohesion. Next, scalability and performance consideration. The scalability consideration are horizontal versus vertical scaling, load balancing, and database sharing. The system consideration in system design are authentication and authorization. The authentication is very important in the security consideration, and the data need to be encrypted before sending. Next, secure coding practices. Implementation strategies. The implementation strategies are incremental development, parallel development, then Big Bang versus iterative implementations. Software development models. The software development models involves waterfall model, agile methodology, DevOps approach, etc. And prototype model also it's there, which is more efficient than the waterfall model. First, waterfall model. The waterfall model is a sequential development process. Its pros are clear structure, well documented. Its cons are inflexible to changes. So, in waterfall model, the The components are arranged in a sequential manner, so it will like a waterfall. So, and it is very clear structure. Every components has clear boundaries, so it is very clear structure and can be well documented as it is very clear structure, so it can be documented easily. Its cons are inflexible to changes. The changes cannot be happen. Next, agile methodology. The agile methodology is an iterative and flexible approach. Its pros are quick adaptability, continuous feedback. Cons are requires constant team collaboration. So it is also in agile methodology also it's an iterative and a flexible approach. It is very flexible when compared to waterfall model. DevOps in system implementation. The DevOps are defined as it combines development and operations, uses continuous integration and continuous deployment. Here, deployment means it is like a delivery, testing and quality assurance. Testing means after developing an prototype or a model, we need to test with the different values to check the correctness of the system or a prototype or a model. Here there are three testing: unit testing, integration testing, system and performance testing. Next, deployment strategies. I have already said deployment means delivering a model or a prototype to the customers, other users. Here, deployment strategies are blue-green deployment, rolling updates, and can releases. Monitoring and maintenance. The monitoring and maintenance are very important for the future development. Log management. We need to manage the logins and logouts through the databases and the performance monitoring. We need to monitor the performance of the model or a prototype. Next, bug fixes and updates. Case study web application system design. Case study web application design. Architecture microservices. Technologies React, it's a front end, and Node.js are the back end. PostgreSQL are the database. Distributed system design. The distributed system design uses of load balancers and replicated databases. It's used for fault tolerance mechanisms. Challenges in system design and implementation. The challenges are handling large data volumes. It's very challenge to handle the large data and ensure high availability and manage security threats. The future trends are it's same like AI-driven system design and serverless architecture, blockchain-based systems. The conclusion: well-structured design ensures reliability. Implementation must be tested and monitored. The future innovation will enhance system efficiency. So thank you for watching this video.